Hello, and welcome to another episode of Your Seat. Your Seat is a podcast about American innovation and startups. This week, we have a special guest, Ethan, the founder and CEO of Creative 3D Technologies, a company building distributed manufacturing through 3D printers. This week, we're going to talk about his global expansion and the importance of supply chain resiliency. I hope you enjoy, and I'll see you soon. Thanks, Ethan. I'm excited to hear more about your company. Welcome. Why don't you tell me a little bit about
Thank you. Yeah, appreciate the opportunity. Yeah, sorry, did you say about me or the company?
Wherever you want to go with it.
Well, my own passion, ambition definitely fueled the whole cycle of the company. So I guess starting with me has been a bit helpful. I became the youngest founder in the entire industry back in 2017. And prior to that, I had a company within the industry, we're talking 3D printing industry here, that really gave me a lot of in-depth knowledge on it and how it's, my own opinion, playing people and not the most consumer-centric or beneficial to the consumer dynamic-wise. And we had a lot of insight in that front and eventually want to innovate and do better. I've always grown up seeing the exciting developments people have made technologically, seeing them in the news. I'm really getting excited for what the future could hold. And I like the idea of being able to help enable that. And if I can make my own technology that helps people do a lot of that without the constraints of, is this thing manufacturable? How can I do so? Can I afford to manufacture it? How do I distribute it? Go through the whole process and really start to decentralize and distribute that manufacturing power and empower that ability to create without those constraints. That's what really excites me.
Okay. So you were a very young founder. How did you find yourself on this entrepreneurial path?
Unintentionally, I'm definitely new to startup culture. I'm not new to business as a whole. So the first company I had, I've been working in 3D printing ever since the patents initially dropped. And when those patents initially dropped on technology, despite being around since the 80s, that's when everyone flooded in. That's where the headlines are saying 3D printers are going to be in everyone's home. It's going to be like the Star Trek replicator. And then that presence faded out a little bit. But that's right when there was all in those headlines. That's when I was in the industry, since I was a mentor advised, hey, you should buy one of these. You have 3D modeling skills. It'd be a cool tech toy for you. And it was. But I quickly realized, instead of just making little personalized gifts for family or friends using my 3D modeling skills, I really enjoyed designing and making parts to make the 3D printer better in the first place. And that improved on. That's how a lot of the industry improves so quickly, because it's engineers, it's hobbyists, it's thinkers buying these technologies and innovating on it, because that's what we do best. And eventually that turned into me having a really deep understanding on the machines. And I was like, oh, well, there's this one that's usually this crazily expensive, I think like $10,000 machine. I saw it for $250 because no one was buying the broken machines because it was a newer industry. And I bought it broken. I fixed it up in under 2 hours. I 3D printed and redesigned a lot of parts that were broken. Spent about $50 to do so, and then sold it off for over $4,000. And that's when I started realizing, for 2 hours of work, that can now buy me more. And now I knew one more platform, and it grew and grew and grew until there was a full, proper business out of it. And that business, instead of just buying printers and fixing them up, because we were one of the first, we did start to get a bit of dependency market-wise from us, but we also started to innovate on it. Instead of just buying the printers broken and fixing them up, because we're redesigning and 3D printing the parts in-house anyway, let's make them better. Let's add new features, let's add new functions, and make the printer a better platform overall, and then sell to a customer. And then OEMs are looking, why are these printers incrementally or exponentially better than what we sold them at? And then that started getting some attention, and eventually we started making a lot of innovation for some of the larger OEMs out there for over 5 years. And that just kind of snowballed from there. Like, oh, well, we know all the pros and cons of the market because we've been doing this for so long, and we have a lot of dependency from these folks, and we knew exactly what they did right and wrong and all their process timings. And what if we made a machine that disrupted their full current dynamic and did things better? And that really helped inspire this company and going down that traditional startup and entrepreneurial route, since it is a different dynamic. It's not something that you can just build one machine to build four more and steamroll like we did the other one, and you need to have that proper startup plan. And that's kind of how we got this one started, with the idea of disrupting the current market dynamic. 3D printing marketplace is very fragmented. I like how our salespeople put it. They ask, how many washing machines do you own? One, most likely. And that one machine gets all you need done. You don't have a separate washing machine that does bulks, a different one that does delicates, a different one that does reds, blacks, whites, whatever. You have one washing machine. If you look around, if all the people who are buying 3D printers, they don't have one printer, they have a lot. One to do your big parts, one to do your plain detailed parts, one to do your metals, your carbon fibers, whatever. And God forbid you need a part that mixes multiple of those printers. You're gluing it together and hoping God it works. Or you can disrupt the marketplace, make a solution that's more than 98% less expensive than close competition out there, and bring it all into one and kind of be that one washing machine ship for the industry, and empower a lot of those people's ability to create, innovate, and iterate a lot more affordably. And that's where Creative 3D Technologies comes in, and that's a lot of the inspiration behind them, why we started the entrepreneurial journey, since we can't fall into this single format of typical hardware startups, raise some capital and then have China make and distribute and do everything else. We have designed a design method that goes against most traditional engineering and manufacturing techniques. Make a production method that's the only production method in existence that can make these really complex shapes. And those complex shapes ultimately in the printer enable new functions, new features, new capabilities. And then we made the machine. If that didn't work, restart over 280 times. And well, because you need a whole factory to do it, you can't just start that off inexpensively either. So that's why we had to go down a traditional startup path of not just bootstrapping, but prepping to raise and showing market impact and everything else. So different market dynamic than what we're used to, but it's been an exciting journey nonetheless.
Nice. What do you remember? What the first thing you 3D printed, and how old were you?
Gosh, I think the age was, I think, around 11, and I think it was because it did start as little trinkets, fun things like that. I think it was a little ghost, like 3D ghost from Pac-Man. And it's always been fun whenever I had new printers, I'd do the same one over again, just see how much it's changed, which has been really exciting and what we can do with it. So I've got like little metal ones, I've got ones that like carbon fibers, I've got like a chocolate one, all sorts of weird little ones that typically take all these different printers, which is exciting.
How many do you have now? Because it seems like
there is a big bucket of them because it's been fun to pile them up, and there's been a lot of printers over the years too. So there's a bucket's worth. I think garbage, like kitchen garbage can size, so larger bucket. We also have that of there's a little tugboat out there called the 3D Benchy. It looks rather simple, but it's built to be a benchmark, thus Benchy. Mm-hmm. And so that's the one that we'll do to test a lot of the iterations. So when we were doing those 200 redesigns, that was the first model we printed out, because we can look in, we can read, okay, well, this is doing this well, and this isn't performing, whichever, and well, read that to make a better printer. So we have another even larger bucket full of those at the warehouse.
That makes sense. Okay. So of all, I mean, you're smart. Of all the different industries that you could be innovating and spending your time in, why are you passionate about 3D printing and distributed manufacturing?
So I think those are two very separate industries. I mean, 3D printing is a step in the right direction. It's not distributed manufacturing proper. It is an excellent method to start to decentralize a lot of prototyping methodology and starting to take the right steps, but it's not full-on decentralized manufacturing until we've made it so, which we're getting to, which is exciting. But I think 3D printing is so exciting to me is just because of the lack of constraint. Right when I approached it, because I was starting to build a lot of engineering knowledge at that point, right when I approached it, I knew there was a lot of opportunity on that side. I am going already through the college courses I was in at the time. It was telling me that, okay, well, engineering right now will teach you not what to make, but how to make it. These are the shapes that are manufacturable. These are the shapes that aren't. These are how you document making it. And these are the machines that can make it. It's not telling you what to make. It's giving you your instruction book on how to make it. And when you have a technology, which this is partially why it's so hard to find developers, when you have a technology that says all that you just paid that what, $50,000 to $80,000 a year for the past couple of years to learn, that said it couldn't be done, well now it can. And just that lack of constraint of not being confined to, oh well, if you're chipping away the block material, these are what shapes you can and can't make, and be able to layer by layer make these wild shapes. And then if you can approach it from an even more abstracted view, from a custom design methodology, and start to merge in all these different types of manufacturing and printing in there, you can make these things that previously were impossible. And that's, in my opinion, what's been the bane of a lot of technological innovation. I mean, there'll be the best ideas ever on the market. They'll be excellent, but the execution is tough. I mean, because if you're typically trying to design or make something, it's design it up, virtually simulate it, and keep running the simulation until you're as close as you think of it, until it works. And then send it off to China, pay them to make the molds and everything, and then you hope to God it works in market, or else then you have to pay them to do it all over again. And that's an expensive and strenuous process. Even a simulation software costs a lot. But if you can have one machine, have it as easy to use as a paper printer, and you have people that have those design expertises, and you have the material, design it out, click print, feel it out, have a similar tolerance, strength, and everything, and keep design iterate until it's fully finished, and then move to that step, you can afford to make those innovations. And if you have the right network and everything, you can even afford to make those innovations without traditional manufacturing lines. But it's still not there to be fully distributing that manufacturing power, which is why it's still mainly used as a prototyping method. But I very much hope that we can turn into that full decentralized manufacturing, which is what we're aiming for. I can give a little descriptor on that. If the approach of our initial product is all-in-one 3D printing, and a whole bunch of different suite of printers in one, we're evolving upon that by starting to add in full-on formats of manufacturing into a platform that holds zero constraint. So making a lot of different manufacturing methods that were never additive layer by layer, making them additive, and in one machine being able to and then make a full product, including semiconductors, including circuitry, including wiring, including paints, coatings, finishes, things like that in one box. And because that is so much more efficient in doing it in one box than having 10, 12 different cells in a production line, and someone to manage all them, the waste associated with all them, the power consumption, the assembly after you've made those parts, the supply chain, the fuel that those take, and all the distributors and factor in the middlemen. Even if you're not as efficient as a full suite factory like China for an end product, in terms of output quantity, we can still beat them, especially the more complex the product is, in terms of a final cost of product. We can't beat them in parts because they're too efficient in parts, but for final product assembly, the more stations it requires to make that thing, that's when we start to be competitive. And by mixing in all your different production methods into one platform, you can make, first of all, wild parts that go against any engineering knowledge. And so when we're requesting parts from any other manufacturer that we can't do in-house, they're looking at us like we're crazy half the time, which is funny. But that's how I see people being able to not only decentralize but distribute that manufacturing power. That's what gets me excited. That's what I see as the full no constraint, pursue whatever you want, be able to think it up, design, and have everyone in the entire world instantly have access to that without having the whole supply chain. And if you can do so cheaper, and if you can make people make money off of that too, then you've got a winner there.
Very cool. Well, why don't we shift gears and pop up your pitch deck?
Yeah, so I'll preface that this is a little bit different than a standard pitch. I mean, we're not looking for standard capital for typical expansion reasons. We haven't needed to pitch in a little while, but we have been pitching international expansion and building factories in different continents to best suit the market. I mean, we've been seeing the market growing rapidly, and if we can make a factory to and maintain the exact same level of quality control as we make these crazy manufacturing devices anywhere in the world, and actually have that factory meet the output of that continent's demand, it saves us quite a bit. So we've been starting to look at India, starting to look at Asia, because that's going to be one of the biggest frontiers for 3D printing, and that's what this deck pertains to. So starting off, we're looking at the executive summary, talking about the company and how we aim to become synonymous with 3D printing and manufacturing by starting to distribute that manufacturing power through technological prowess and innovation. So we make machinery capable of encompassing and combining the typically separated functions of entire suites of 3D printers and entire factory production lines in single all-in-one powerful platforms that can do it all. So we start to go into the first product, which is the one we were talking about a little earlier, Evo. So we started addressing from 3D printing in that market dynamic of you are supposed to buy a specific printer for a specific price point. You want to do large parts, for example, and that's all you want out of your printer. Great. You have $50,000 budget. There's essentially a very set few of companies that you go to at that price point. Now, if you have a $70,000 price point, you still only want your large parts. It's a different batch of companies. So their competition is not exactly direct right there. So the price is high and quality is lower. You want that same printer that's doing like chair size parts to do something closer to a glass of any precision. That's a different printer. You want that same printer to do coin face detail. You want metal, you want carbon fiber, you want food, ceramics, silicon, or even if you want feature sets like NRD full, Industry 4.0, and IoT connected. Those are all things that define your own sub-markets of 3D printer, and you get your single function solution for that one market with very few people competing. So the market lacks innovation and price is high and quality is low, and that's exactly what we're targeting. So our solution to that is building a platform that has the speed, precision, tolerance, electronics, essentially be any kind of printer. Do it at a price point that literally no one can compete with in the marketplace, because no one can price more than 95% less than what they're currently pricing at. And if you're able to make that solution outperform all the printers you're encompassing, it's kind of a no-brainer. So even though we're a jack of all trades, we're a master of them all. You want your large parts, great, and you don't care about 9 other types of printing. We're more than 80% less than the closest person to us than just size alone. We'll print the exact same full part in 10% of the time it takes the competition to make the entire part, typically, with finer detail, and again, for less money ultimately. You want metals, 99.99% less expensive. We make metals that were never before printable, and we can do all these unique shapes, geometries, reduce 95% of the waste associated with printing metals, and outperform just that one function. And the list goes on. Duo Evo is a tool that can do quite a bit all in one, better than anyone else, and that's kind of what we start to dive into. You can see all the specialties there towards the bottom. Evo encompasses large part printing, high-speed printing, high-temperature printing, fine detail printing, smart printing, batch production of parts, multi-drill parts, abrasive, reinforced parts, flexibles, metals, pellets, paste, and a whole lot of other things all in one. And then you can see how it compares to the close competitor and then exactly how much less for each of them as well. And on top of that, you can combine these typically separate formats of printing to make parts that were never before possible. This is how we're entering the market, and that's how we're getting ourselves profitable, and we're using a lot of profits from that to fund single cell production. So in terms of single cell production, we talked about it takes tens of millions of dollars of machinery to build a single product. And each machine in that process has waste that over demands resources. Factories are the largest demand of both material and power costs right now. And there's machine waste, there's assembly, there's distribution, middlemen, and that all factors into the final cost for a product. So if a machine were being made that can encompass most of those steps, and even if the output isn't as high, sorry, though it's a little dry. Even if the output isn't as high as a traditional factory, we could win in cost per product through technological innovation by building into a single cell. So Dyad Shift is our solution. It's the vision of how we can shift production power. Since encompassing manufacturing, an all-encompassing manufacturing tool is a new machine, we actually get to name the industry, which is exciting. We get to name a full sector technology. So if you 3D print a part, we 3D fabricate the product. So Dyad Shift will be the first platform for 3D fabrication. It utilizes the same unique in-house design principles and production technologies with an absolutely no compromise platform. So we're able to hit 1 micron encoded precision and move several feet per second with multiple carriages on the axes and a lot of crazy technical parts. And we're able to empower that decentralized production by having disruptive business tactics go along with it. It will be initially aimed at businesses, but after targeting those businesses, shift to consumers. So how will we make an everyday consumer buy a $50,000 product? Well, we'll kind of act as a marketplace. We'll offload initial demand that's going from a lot of these businesses to traditional manufacturers, approach them saying, hey, we can make your thing on site for less money than it would cost you from those traditional manufacturers. Just work with us through our web portal, someone places an order, that gets sent to the close machine to them and made quickly. And now the customer that owns that machine can make recurring revenue. And we did a case study, and they're making anywhere between $2,000 and $6,000 a month. I mean, pretty passively, other than loading in material like once, twice every day. And if we're able to then expand that to more consumer-oriented products, like one of the first products we approached, they're doing custom in-ear headphones. The idea behind them is take a photo of your ear. They can design something to fit it and then manufacture it, but it's very expensive to do so right now. So we go to them saying, hey, your tools make it, your products manufacturable. Here's all the nodes that can do it. Work with us because we can beat China's prices, and on top of that, take out the middleman, or we go to your close competition. And so in doing that, now that's a product that we bet on our marketplace. You can take your ear pick, get near factory direct pricing, have that sent to a close machine to you, made less than an hour, and pick it up, fully made end-to-end, tailored to you with the exact same high quality parts that typically go in a product. Which, if we have an impact like that with a lot of custom goods, we can then build that network because everyone wants recurring revenue. We then start to shift to automotive parts, drones, and computers, and all sorts of different things. And then you can start to modularize that platform with different tools to manufacture different things. Like if you want to go from preloading a made circuit board to actually making the circuit boards, we're working with a couple of companies that are competing to make modules for this technology. So we're not encompassing a technology that we don't know, that you can swap on. And then as long as you load in a block of semiconductors, now instead of loading in boards, you now print the boards, and you're making one more production method additive. You can now turn a, say, 12-inch by 12-inch board into a less than 4-inch by 4-inch cube suspended within your part because you're building it up layer by layer. And we can wire it layer by layer and go vertically, which opens up a lot of different techniques. Or we can even drop in all the drivers, and say you're making like a drone, we can drop the motors and drop in the motors, build it into the part, drop in the drivers right next to it, and wire it with silver ink in between the layers itself. So similar to Duo, it's still mixing all those different printing formats in one, but now starts to add in all these different manufacturing processes to end-to-end make a product, which gets really interesting. So because we're talking about expansion here, we start to talk about a lot of different use cases and things that we can do. I hear some folks even working on modules to actually make the first ever three-dimensional semiconductors using a 1 nanometer encoded tolerance add-on module that we've been working on. And we're able to make like more components for our own printers. We're able to make complex electronic assemblies without traditional supply chain issues. I mean, as long as you have power, as long as you're receiving material, we can make really advanced parts that you typically wouldn't find anywhere else. And that includes, I'm even going to complex and robotics that goes into batteries, that goes into decarbonization products, that goes into anywhere from biological materials to full medical machinery to consumer clothing and things like that. It goes a bit everywhere. So it goes a bit trying to take a bit of water.
So you can, did you say that you could 3D print a semiconductor?
Yes. Well, innately off dyad, no. It is an add-on module. So if we go here, as a platform, you'll initially get to encompass all your 3D printing types. So it's your metals, your large parts, your small parts, your fibers, your ceramics, your silicone, your paste, all in one platform. So unlike Duo, it's autonomously swapping between all those in the same parts. So you can make your metal, have flexible, have all these parts in it. And then as we're going, then we start to swap in manufacturing tools. Like there's a different model that is included in the base package that does multi-actual milling. So prints have layers, we eliminate the layers by smoothing it out. It makes it look like an injection mold part. Prints have monochromatic colors usually, so we actually implement inkjet coloring. We add in pick and place so we can drop in screws, bolts, inserts, add-ons, electronics, whatever, as you're building it up. And a couple other things in the one platform, machine learning, so we can make qualified parts, which is the biggest issue in the industry right now. If we're taking more data than anyone else, we know exactly how much material is supposed to be in this part, how much was exactly output, including and accounting for deviation material itself. And then also using machine learning to cross compare each layer of the part as it's printing to the actual CAD model. You can set a margin of error, and we can tell you, hey, this fits your margin of error, and the right amount of material is in there. It's qualified now. And then when you're talking about aerospace, when you're talking about aeronautics, when you're talking about anything that needs to be in a tolerance, we can now guarantee it on the same platform. But if you want to improve upon those base capabilities, like if you want to go from just picking and placing a pre-made board to making the board, that's when you start to buy the add-on modules. Like if you want to do that, then you buy the tool head that can actually lay down the board substrate. If you want to then, instead of just now loading in a brick of semiconductor, if you want to make the semiconductors instead, there's a full add-on module of pressure, heating, cooling chambers, and robotic arms, and 1 nanometer additional technology that we have that can now make that semiconductor in our additive format and build it into the part wherever you need as well. So you can modularize it. Even if you want to go to and make the first ever personalized medicine be feasible, there's a similar full suite modular add-on attached to the side of it that can now start to bring that in there, along with if you want your part to be coated, polished, and painted, if you want it to be fully sintered, and there's all sorts of different modules that you can add onto this. And we're essentially giving you the factory in a box, and you can customize it to make whatever you'd like. But for a base price, we can certainly make a whole lot more products than anything else out there and make it a recurring source of revenue for customers. So if you're near like a bunch of hospitals and say, we get approved for more medical, then, and you live near there and you have one of these, you want recurring revenue, you buy the medical add-on module since you're closer, those customers are going to be buying that. And that's how we start to distribute the workload instead of trying to have someone now place an order from a machine that's very far that has the closest medical module. So this slide just started diving into, like we were talking about, a lot of different ways to do so. And then we start going into why we're looking at India, since we've been using this proposed to governments and a couple of folks. The Asian continent is a very strategic play for us. Market trends are showing an already 16.8 billion in the marketplace is going to continue to grow at CAGR of just over 29%. And it's currently being reevaluated as a higher interest in investment in 3D printing and fabrication technologies at an all-time high as a result of all these supply chain issues. So it's really highlighted the need. That year-over-year growth, if we have a product that's more than 85% less expensive and can outperform a whole lot of other technologies, we get to corner that marketplace. And we're better than to add a new facility to where a lot of that larger growth is happening. And that's why we're starting to look at Asia. We're initially looking at Japan, but India has been making some compelling offers as well. So that's why we made this deck. So Asian continent will be quickly it is the fastest growing market, and it will be the first largest consumer of it. Let's put a factory out there that can do so. And that's a strategic position for us. And then it's more affordable for us to have that larger facility. It's great distribution channels and retail partners already. We can better target the continent's demand and continue to expand that same facility to meet that continent's demand as it grows. And it's a great play in a continually growing market. So that's why we're starting to look at our first international expansion being out there and just the affordability behind it. And because we developed our own smart production line that really dummy proofs the whole production process. It says, hey, you want to assemble this part, grab parts from bin A. Bin A then highlights, and we use machine learning to know which bin you're grabbing from. If you start to grab from bin B, for example, it flashes red and tells you have the wrong part. And there's a video guide, there's instruction, there's weights, everything, even down to the screws. You can't even torque the screw wrong because it's set to a set amount of torque. And then you put the screw in the right position, the torque center, we have a full record backlog of every single screw, how tight absolutely everything is in the printer. And as long as we have someone that's the native speaker to translate it, we can now maintain the exact same quality control internationally with different production partner folks. So in terms of factory plan layout, we're looking for a proper partner to help us establish that, establish the entity and facilitate investment to begin laying down groundwork for the factory, because it is going to take a while to get up there. What we've designed out is designated about 100,000 square foot facility that's capable of housing about 1,320 units of inventory initially through some advanced inventory management systems. And in terms of manufacturing output of both Duo, Evo, and Diet Shift, initial maximum capacities would be about 760 units per month of each unit respectively, which turns out to be 8.74 million and 38 million worth of output respectively. And we actually have the marketing metrics and everything to back that as well, and demand to back that as well. Output can actually be doubled without moving location, just given how spatially efficient we are and how different our production lines are than most things out there. And a production facility, as mentioned, it'll use our proprietary smart production line workstations, tools, and assembly steps to ensure the exact quality of the US facility. And in addition, it's going to help offload demand from the EU facility that we're also setting up and the US one as well, by having a higher output if they need it, because it's just so well positioned in terms of distribution. So in terms of market size growth, we talked about it a bit, but most key points here, the CAGR and marketplace value at what we're going at. And there's a lot of demand. And the main thing here as well is that our TAM, because most of the reason why other 3D printing OEMs have much larger total addressable markets is because they're segmented, they're fragmented. It's like, oh, well, we're targeting the middle market, we're targeting the large format market. Given that we're targeting just about all of it and we're relevant to any consumer, anywhere from the high-end hobbyist that's making revenue out of his garage to buying the world militaries and Fortune 500 companies, our total addressable market is, if we're taking a lower estimation, upwards of 50% of the total market value, and continues to grow proportionally as that goes up as well, given that our format of 3D printing is having the highest amount of growth in the marketplace as well. So in terms of traction, we start to dive into things. We initially, if we want to go way back, we first started pushing this in the market. We opened up orders for less than a week before it shut them down pretty quickly because we had over 270,000 in orders within that time frame. And then we started to build a backlog, and that's when eventually we decided, okay, we can't do this out of a tiny garage in Chicago. Let's scale up. Let's do this in Austin. Let's build something up too. So we've now have the Austin facility, and we're starting to push output here, which is doing extremely well. And we're actually able to meet on some of the demand we had. But we've turned the heads of the market. We've gained massive interest again. At these shows, we just let people abuse the thing and told them, interact with it, feel it out. And at these shows, you can't get close to machines, much less touch them. But when you're the startup with no marketing or anything and just have a unit there saying beat it up, it made it fun for a lot of people. They loved it. We turned heads to the industry quickly, and that's when we realized that our tactic of corner the marketplace of something that much more capable and that much less expensive worked a little too well. And that's why we're playing catch up, and that's why we're looking at this expansion so early so we can stay prepared. So now we're scaling up, and we've been doing very well. Even at shows that people said were slow, we've had nonstop amounts of interest, and now we need to start facilitating that demand because that's all pre-marketing. Other than a social media post of 50 followers at the time and showing up to a show, now we have great sales teams, now we have great marketers and everything. We're a little nervous and we need to scale up quick. So in terms of what we can do financial forecast wise, if we're doing a very low demand estimation, because I'm very much on the side of under promise by quite a bit, over deliver. This is what we're looking at, especially given it's a hardware product and how well or how nice our margins are. This is pretty inclusive if we're doing the absolute minimum in both modular add-ons and unit output. And this is pretty in line with what we are starting to see out of the EU plant that we're looking at as well, which is exciting. And eventually we'll subsidize more of that demand stream. So we're looking at Creative 3D Technologies putting in about 15 million closer to 2025 for this factory. And if we can find a partner a little earlier to on the 5 million side, that's going to help us in that partnership side as well. That's about what we need to really get things rolling on that foreign front and have that factory with pretty low overhead and recurring revenues. And there's a much larger financial breakdown to go with this. In terms of terms, we're looking at setting up a foreign entity and facilitating, have that facility be the first production line for diet shift and to really scale up on Evo and any additional add-on tool heads that we have with it. As even we've had some retail partners look at us and say, hey, can we start out with like 3,000 units a year? And right now we cannot do anywhere near that. Output wise, we need to expand quick. So, and that's why, again, that's why we need that added facility soon. But we'd be looking at starting a separate entity out there, and we'd give equity in that entity, and it'll reflect the present value. And that'll correspond to some equity within the US entity as well. So we'd be looking at about 10% on that front. In terms of exit, we're currently in progress of becoming an industry leader because we've been cornering a lot of growth and demand. It's going to take a while for anyone to compete. And that is contingent on us being able to meet the company's demand and facilitate that position in the market. So within the next 4 years, with the AP Continent being that largest consumer printing, we need to, and by having the industry's best printer there and best and only 3D fabrication, both in the same factory, we can corner that commons demand as well. So that's what we were looking at on the low demand situation, and we'd be returning investment would be a profit within 24 months of operation, and we'd be looking at potential 10-figure exit within 5 years of that being active as well. Just given our traction and given our demand metrics as well. And again, there's full financials to back a lot of this, but that's how we've been pitching to some of the foreign larger parties and folks to help us start to meet a lot of demand, which has been exciting. And that's what I was saying. My schedule has been so bogged down because we've had to hit international expansion, we've had to hit our backlog, had to hit all the partners and all the demand interest that we had way too early on, which is an exciting issue to have, but this takes a lot of planning. This takes a lot of strategy and it takes the right partners too. So that's why we're looking now for it. Be prepared, start early. But
Yeah.
that's where we are.
This looks incredible. I can see why you've been so busy. Thank you for making some time to chat with me and share what you're doing. Just quickly, as we're sort of wrapping up,
Sure.
what would be the number one thing that you would need or looking for right now, besides more time?
Well, we are hiring for quite a few positions. I need to delegate, and at least the biggest one that we're trying to find. I think is definitely the hardest is trying to find a COO that has a lot of that taking a company to IPO experience and doing so in a very relevant industry is something that I value a lot. I'm essentially looking for someone, another me, which is definitely tough to find in a lot of ways, but I'm confident we'll eventually get to them.
With the
So
bioprinter,
looking.
you should just be able to print a new one, right? A new one. Is that how
You
they do?
know, I think we get into some pretty deep topics with that since we might be able to make the body, even though it's not been medically approved so far. But then
Oh
what's
God.
can we fill the brain? How do we do that? Do we
uh,
make a human AI? But hiring is a lot of what we're looking for too, and we're looking for strategic partners in our larger international expansion. And because we've had some folks commit funds to actually current rounds in the U.S. entity that after we got some exciting titles and built a lot of excitement and traction behind us, people got a little too excited, overcommitted funds that they didn't really have. So if someone's interested in making up for them and can be a valuable strategic partner to us, great. If not, honestly, we can make do without it as well. But I value having strategic partners within the company too, and definitely see them being a help as we continue to expand. And that's why I try to look for them. And if we have a good opportunity like that for a lower check amount that can really push some value with us, we're open to it too.
all right. I hope you enjoyed this week's episode of Your Seat. If you like this episode, go ahead and hit the like button. And if you want to get a hold of Ethan and learn more about his technology, you can find his contact details right here on this page, and you can reach out to him directly. I'll see you next week. Thank you.